For lab 4, you first need to calculate what the concentration of cobalt and copper ions are in your stock solution. So when you went to lab, maybe you had a plan that you were going to weigh out about 2.9 grams of your cobalt 2 nitrate hexahydrate, but when you got there, you actually ended up with 2.878 grams. So this is the number that we need to use because it's more specific and it's what you actually did. This only has 2 significant digits and that's what you were aiming for. So we're going to use this one. So we have 2.878 grams of cobalt 2 nitrate hexahydrate. And the molar mass that we are using for that is 291.046 grams per mole of the cobalt 2 nitrate hexahydrate. And then the species that's causing the color and the absorbance that we're looking at in lab is really the cobalt ion. The nitrate does not have a color to it, and the extra water molecules that we dissolved did not have a color to it. It's really the cobalt. And because I'm tired of writing out this whole big long formula, I'm going to go ahead and convert this to just dealing with cobalt ions. So the concentration of cobalt ion is the same as the concentration of cobalt 2 nitrate hexahydrate because there's one cobalt in each of these cobalt 2 nitrates. And I end up with 0.009888 moles of cobalt ions. And then the molarity is the moles per liter. We have 50 milliliters, 50.00 milliliters actually. So the volume of our solution is 0.05000 liters. So if we divide 0.009888 moles by 0.05000 liters, we get a concentration of 0.1978 molar of cobalt ions. So this is our molarity of cobalt in our stock solution. It's close to the 0.20 that we were going for. Actually, if we round it to 2 significant digits, it would be 0.20, but this is a little bit more precise. We have the 4 significant digits here. All right, so for our copper 2 sulfate pentahydrate, we used 1.503 grams, so we can calculate the molarity with 4 significant digits for that as well. Here we have the molar mass. We can convert to moles of copper 2 sulfate pentahydrate, and then to cut down on our writing, we can just convert this into moles of copper ions, make it a little neater. So this is 0.00601971 moles of copper 2 ions, and then that is in a volume of 0.05000 liters of solution, and that comes out to be a concentration of 0.1204 molar in copper 2 ions. So these are the 2 concentrations that we have in our stock solution. Now we need to figure out the concentrations that we have in our diluted test tubes. So I wanted to point out, I think it was in week 4 discussion, there is a pretty long set of discussion problems. We did not get to all of them during discussion, but one of the problems in there is a practice of dilution calculations for lab 4. So let's take a look at a couple of those. If you want to do the rest of them, they're in this week 4 discussion page, and the answer key is there as well. All right, let's practice some of the dilution calculations. Once we have a concentration in our stock solution, so we have a cobalt ion concentration of 0.1978 moles per liter and a copper ion concentration of 0.1204 moles per liter in the stock solution. So that's what we are using here. In tube number 1, it looks like when we do some subtraction, we actually used 0.98 milliliters of stock solution in tube 1. And then if we use these two burette readings, we used 3.98 milliliters. So we were supposed to get about 1 and about 4. This is a little bit more precise than about. We got 0.98 and we got 3.98. So then the total volume in the tube is those two numbers added together. So that test tube now has 4.96 milliliters of diluted solution in it. So let's represent what we did down here with a little drawing. We took 0.98 milliliters of the stock solution, which had a concentration of 0.1978 moles per liter, and then we added 3.98 milliliters of water. So our new volume is 4.96 milliliters, and our new concentration is what we are trying to discover. And we can use a dilution equation. This is C1, this is V1, this is V2, and this unknown is C2. So we plug that into the dilution equation. So here we have our dilution equation. And calculating the cobalt concentration, we use the stock solution concentration of cobalt. This is how much stock solution, this is how much diluted solution. We divide both sides by 4.96 milliliters. And we get 0.039 moles per liter for our C2. I rounded it down to 2 significant digits just because this volume is only 2 significant digits. So this is how we would calculate the concentration of cobalt. For copper, we have the same volumes because we did the same dilution, but the concentration of copper in our original stock solution was not 0.1978. It was 0.1204 molar. And when we do the math on that, our concentration for copper ends up being 0.024 moles per liter, because we diluted a stock solution that was 0.1204 molar concentration in copper. So let's just try the calculations for tube 2. Then if you want to see tube 3, you can look at the answer key for these worksheets. For tube 2, we were supposed to use close to 2 milliliters of stock solution. When I subtract, it looks like we used 1.96 milliliters. And we were supposed to have 3 milliliters of DI water. It looks like we have 3.05 milliliters of water. And so our total volume, once the tube has been diluted, this and this mixed together when we made the tube. And so we have 5.01 milliliter as our new volume. So calculating for cobalt, our C1 is 0.1978 molar. This time we used 1.96 milliliters of that. And we want to know our new concentration of the diluted volume of 5.01 milliliters. And dividing both sides by 5.01 milliliters, I get 0.0774 molar. This time I had 3 significant digits in the volume of stock solution, so I will go ahead and keep 3 significant digits. The stock solution also has copper in it, and so the volumes are the same. Diluting tube 2, we're using the same volumes for the stock solution, which has both cobalt and copper, but the concentration we start with is different for copper. Starting with a copper concentration of 0.1204 molar in our stock solution, and doing that dilution, the C2 for copper ends up being 0.0471 molar. And so then you do a similar thing for tube 3 and a similar thing for tube 4. For tube 5, you did not dilute it at all, so you can keep the stock solution concentrations with the 4 significant digits. So you don't have to go down to 3 significant digits for that concentration.